This is the entire code for the project. As you can see, it is only 13 lines long if you don't count the brackets. I'm gonna assume that you have a little bit of experience with programming, but if you don't, I will put a few links in the description. If you have even a basic understanding of Java or C++, this should look familiar to you. The syntax is basically the same in the use of parentheses, semicolons, and brackets. In the IDE itself, the code looks like this. For our purposes, I will be using this layout to explain each component. First, we declare the variables. Think of this as the part of the recipe where the cookbook author lists the ingredients. In this case, our ingredients are 3 numbers, or ints or integers, although only one of them is really important. We start by declaring the sensor pin. This is the pin on the Arduino where we have plugged in the output from the sensor. In my case, it is pin A0, but if you have used a different pin, you would change that value to reflect the name of the pin. The IDE already understands what an Arduino is and has libraries built into it, so there are some things that you will see we don't need to import from another library or define in a different way. Next, we declare the LED pin. Just like the sensor pin, this is the pin on the Arduino where the input for the LED is attached. In my case, it is pin 13, but if you have a different pin, again, change that value to reflect the name of that pin. After that, we declare the sensor value and initialize it to 0. This is the most important variable, because it will tell us what value we are getting from the sensor. I have set it here to 0 because we want to start without the sensor giving any value. Also, it would default to 0 anyway. There are 2 main components of a code written in the Arduino IDE besides the declaration of variables and the importing of any additional libraries that you might need. The first is the setup, where we tell the Arduino how to get started. Void is a little hard to understand if you're relatively new to programming. For now, an easy way to think of it might be as a command. So in this line, you are commanding the Arduino to get set up. Pin mode is a term that the IDE already understands. It basically tells the Arduino what a pin is going to be used for. Here we are telling it that the LED pin, which you recall is number 13, is going to be used as an output. This line is also a little complicated to explain if you are new to programming. Basically what it does is start the serial monitor. The serial monitor is a panel within the IDE that we can open where we can display data from the Arduino. This command starts that process. The second main component of the code is the loop. This is the part that gets repeated over and over and over again. In this line, we command the Arduino to start the loop. The way this code works is that we get a value from the sensor that corresponds to the wind or breath speed that it detects. We then use this to turn the LED on or off, depending on how high the value is, which is to say how strong the wind or breath is. So the first thing we need to know is the value from the sensor. This line tells the Arduino to read the value coming from the sensor pin, and it tells it that it will be an analog rather than a digital signal. It then updates the sensor value to whatever that signal happens to be. So if there is no breath detected, the value would be 0. If you blow really hard on the sensor, the value might be 700 or more. The next line is where we use the serial monitor. Specifically, we are telling the serial monitor to print the value from the sensor. You would read this as serial print line. The code will work just fine without this bit, but you will probably find that it is useful to know the value that the sensor is reading. You can use that then to tweak the code. The last part of the code is what we call an if-else statement. It means that if some particular state is achieved, something will happen. If that state is not achieved, something different will happen. In our case, the state to achieve is a high breath speed. If that is achieved, the LED will turn on. If that is not achieved, the LED will turn off. Here I have defined a high breath speed as over 540. Exactly what that means isn't important for now, and you can use the serial monitor to check the values that you get from your sensor, and then you can change this number if you want. So, if the value from the sensor is over 540, the Arduino sends a signal to turn on the LED. Just like we used analog read to get data from the analog sensor, we use digital write to send data to the digital output. In this case, we want the data to be high, because that is the Arduino term for turning on the LED. You could think of it as turning on the high beams on a car. Otherwise, if the condition of a sensor value greater than 540 is not met, we need to tell the Arduino to turn off the LED. If and else are pretty common terms in a lot of programming languages. You can think of it as if X, do Y, or else do Z. And of course, in this case, we would want to turn the LED off if the sensor value is less than 540. We do this in pretty much the same way that we turn it on, just replacing high with low. Now, I want to try reading through this code in as plain English as possible. From the top. The sensor is plugged into the pin called A0. The LED is plugged into pin number 13. The sensor starts with a value of 0. The Arduino gets set up. The pin with the LED is going to be used as an output. The serial monitor starts. Repeat this part over and over. Get the value from the sensor. Print that value on the serial monitor. If the value is over 540, turn the LED on. Otherwise, turn the LED off. I think that sometimes programmers can get bogged down by the specifics of syntax in their code, and they forget that the reason programming languages exist is to make things easier. If you've ever used machine code, you will know what I mean. I think this would be a good project for an intro-level programming class. It is very simple, but it also shows how to use variables, how to use an if-else statement, and how to use some interesting bits of hardware that take programming away from the screen. Now that we have the wiring and the code completed, I would like to show you a breathing exercise that this device can assist with. Box breathing is a system of breath regulation based around a count of 4. Sometimes it's called Foursquare Breathing. And this is how it works. You breathe in through your nose for 4 counts, hold your breath for 4 counts, breathe out through your mouth for 4 counts, and again hold your breath for 4 counts. As you breathe in and out, make sure your nose and mouth are close to the sensor. That way, you can use the serial monitor within the IDE to check how deeply you are breathing. You can use that information to change the threshold value that turns on the LED. Then, you can use the LED as a guide to show when you are breathing nice and deeply. Let's try it.